So welcome to apcalculus. Here we will learn a few cross-sectional formulae. This is basically a topic on definite integrals. So a few cross-sectional formulae. Area of a square is s squared. Area of a semicircle is half pi r squared. Area of an equilateral triangle is root 3 by 4 a squared. Area of an isosceles triangle will be half s squared where s is the base. This is with respect to the cross-sectional area. An area of isosceles triangle will be 1 by 4 s squared where s can be the hypotenuse or the base. So let's start with a few problems. Find the volume of the solid whose base is the region bounded by the curves y equal to x squared and y equal to x. Cross sections perpendicular to the x-axis are squares. So we first find the points of intersection of y equal to x squared and y equal to x. So solving simultaneously, when you equate x equal to x squared, x can be 0 or 1. When x is 0, y is 0. When x is 1, y is 1. So your points of intersection are 0, 0 and 1, 1. So if you draw the graph, this is the straight line y equal to x and this is the curve y equal to x squared. Now for cross section for a square it is half. Cross section for a square is just s squared. So volume will be left limit to right limit, x equal to 0 to 1, right top curve minus bottom curve, that is x minus x squared the whole square dx. So when you expand this you get x squared minus 2x cubed plus x raised to 4. Integrating you get it as 1 by 30. Question 2 is find the volume of the solid whose base is the region bounded by the curves y equal to x squared and y equal to x and whose cross sections perpendicular to the x-axis are semicircles with diameter spanning the vertical distance between the curves. So again, as we saw in the earlier problem, points of intersection are x equal to 0 to x equal to 1, and for a semicircle area of cross section will be pi by 8 top curve minus bottom curve the whole squared. So that is pi by 8 x equal to 0 to 1. Top curve is x minus bottom curve is x squared the whole square dx. Again expanding it as x squared minus 2x cubed plus x raised to 4. Integral of x squared is x cubed by 3 minus 2. Integral of x cubed is x raised to 4 by 4. Integral of x raised to 4 is x raised to 5 by 5 within the limit 0 to 1. So you get it as pi by 240. Question 3. Find the volume of the solid whose base is the region bounded by the curves y equal to x squared and y equal to x and whose cross sections perpendicular to the x-axis are equilateral triangles with bases spanning the vertical distance between the curves. So again, as we explained in the earlier problem, the curves intersect at 0, 0 and 1, 1. For an equilateral triangle, area of cross section is root 3 by 4 a squared. So it is integral x equal to 0 to 1 root 3 by 4. Top curve minus bottom curve, that you can see as in the previous question, x minus x squared the whole square dx. Again integrating as explained in the previous problem, it is root 3 by 120. Question 4. Find the volume of the solid whose base is the region bounded by the curves x equal to y squared and x equal to y plus 2 and whose cross sections perpendicular to the y-axis are isosceles right triangles with legs as the base and height. So we find the points of intersection if you equate y squared equal to y plus 2, y equal to 2 or minus 1. If y is 2, x is 4. If y is minus 1, x is 1. So your points of intersection are 4, 2 and 1 minus 1. So this is the parabola y squared equal to x and this is a line x equal to y plus 2. So cross sections of an isosceles triangle will be half s squared. So that will be half. Here it is y equal to minus 1 to 2. So right curve is y plus 2, left curve is y squared the whole square dx. That will be y squared plus a plus b plus c the whole squared. A squared plus b squared is 4 plus c squared is y raised to 4 plus 2ab which is 4y plus 2bc which is minus 4y squared plus 2ac which is minus 2y cubed dy. So integrating you get it as y raised to 5 by 5 minus, when you simplify this you get y raised to 4 minus 2y cubed minus 3y squared plus 4y plus 4. And now integrating, integral of y raised to 4 is y raised to 5 by 5. Integral y cubed is y raised to 4 by 4. Integral y squared is y cubed by 3. Integral y is y squared by 2. Integral dy is y. So you get the answer as 81 by 20. So we have learned how to integrate cross-sectional area in problems in definite integrals. Thank you.